Welcome back. I hope you enjoyed the 3 previous modules. In this module, I will talk about various commercial object-oriented programming languages and databases. First, I will talk about the programming languages, and then I will talk about the databases. Finally, we will talk about case tools. In the module 1, I described, I emphasized on 3 various aspects of the technology. 1 is the user interfaces, 2 is the programming languages, and 3 is the databases. We will not be going too much in detail of the user interfaces, but I will place our emphasis more on object-oriented programming languages and object-oriented databases. First, the programming languages. In the recent past, we have witnessed a plethora of programming languages that claim to be object-oriented. And these programming languages can be broadly grouped into the following categories: the pure object-oriented programming languages such as Smalltalk, Eiffel, and Actor; C-based programming languages such as C++ and Objective-C; Pascal-based languages, Object Pascal and the successor Ada and Oberon; Lisp-based languages such as Flavors and Class; Prolog languages which are based on Prolog such as Full Control Prolog; and there are a number of knowledge-based expert system development environments which have several features which I described in the object-oriented systems overview. There are Lisp-based languages such as Key, Art, KnowledgeCraft; C-based languages such as Kappa, NXpert, and Art. Let's have a look at how these languages have evolved over the history of programming languages. Most of the languages have been influenced by ALGOL, which was developed in the early 60s in the research area. Note that when I talked about the evolution of object technology, I talked about more from an industrial perspective. However, in the research field, there were a number of languages which were object-oriented and developed at that in the early periods around 60s and 70s. Lisp is a language which was developed for artificial intelligence applications, and from that the flavors and loops evolved in the early 80s. Loops is Lisp object-oriented programming language, and flavors also is an object-based version of Lisp. Class is the current standard of Lisp, which is Common Lisp Object System. In this diagram, the red boxes indicate non-object-oriented languages. The blue boxes indicate, or the cyan boxes indicate, the pure object-oriented languages, and the green boxes indicate the hybrid object-oriented languages. So, in terms of the evolution of these languages, Simula, Smalltalk, and Eiffel evolved from ALGOL, C evolved from ALGOL, and C++ evolved from C. There are several versions of Smalltalk. Current version is Smalltalk 80, and there is also a version on the IBM PCs called Smalltalk 5. Actor is a version of Smalltalk on IBM PCs, and it's little more efficient than Smalltalk. Objective-C has got both the good elements of Smalltalk 80 and C. What I am going to do in the next few slides is to describe some of these programming languages, compare these programming languages along several features. In particular, the features that I will be focusing on are the following. 1. Binding time. We talked about dynamic binding. Now, whether the binding is done during compile time or during runtime, and also whether the binding is done for in terms of variable binding or message binding. In other words, some languages such as C++ offer static binding for variables and dynamic binding for messages. So, we will look into these two, both the messages or the behavior and the attribute values or the structure and see when the binding happens during compile time or during runtime. The second issue is dynamic object evolution, that is, how easy is it to modify the objects during runtime and compile it and link it during runtime. Efficiency is how efficient these object oriented languages are, what kind of encapsulation they provide, do they provide garbage collection or not. What is garbage collection? When you are using these objects and dereference these objects and you no longer need them, you need to delete them from the main memory and collect the free addresses that are available. Some languages such as Lisp do the garbage collection for you automatically. However, on the other hand, languages such as C++, you have to do the garbage collection yourself. Associated with dynamic object evolution, we also have incremental linking, where you can develop objects on the fly and incrementally link it along with the other parts of your program. In interpretive languages such as in interpretive languages such as Lisp, this is no problem and it's an irrelevant question. However, in languages such as C++, which are compiled type languages, we need to discuss incremental linking. Inheritance, whether the languages offer single inheritance, multiple inheritance, and so on. Parameterized classes are templates. During the break, we had a question on what a parameterized class or a template is, and we will answer that question now. These parameterized classes allow a parameterized template to be written that can be applied in several cases that differs only in the types of the parameters, and these are very useful for providing generic types. It's also known as genericity in some programming languages. What kind of programming environment that these languages provide? Is a programming environment complete? Or the programming environment something where the user has to spend a lot of time doing a lot of work, but and then when there is a problem, you don't have sufficient debuggers and browsers and so on. Finally, whether these programming languages incorporate some software modules, or whether can you get software modules from other places. We will come to an example of the parameterized class later on, but I will discuss that in perspective of C++. This particular slide here has a lot of information, so you have to bear with me in terms of the size of the font and other things like that. But let me kind of briefly go through many of these languages using this particular slide. What I am going to do is the following. There are several dimensions that we discussed, and these dimensions are given in this in the row here, and the dimensions are encapsulation, binding, operator overloading, garbage collection, inheritance, incremental linking, efficiency, programming environment, dynamic object evolution, parameterized classes, software module, and user acceptance in the future. So these are the various features that we will look into, and in the column I have the various languages. The pure languages such as Smalltalk 80, Eiffel, Actor, and mixed languages such as Ada, C++, Objective-C, Lisp-based languages such as Class, and a number of expert system tools such as Key, Kappa, or an expert. Encapsulation. Smalltalk provides strong encapsulation. Eiffel provides strong encapsulation. Actors provides the same facilities as Smalltalk. However, the expert system based languages don't provide a very good encapsulation. Many times these variables are public. Most of the variables are public, and they don't have a notion of hiding the private variables to the rest of the world. So we can go in and make any of the other objects can make changes in any of the other objects. Binding. Smalltalk allows dynamic binding for both attributes and messages. That means that attributes can take on the type during runtime, and similarly messages can be bound to methods during runtime. Eiffel offers some dynamic binding. It's very similar to C++ because the variables are statically typed. So, although it is derived from Smalltalk, influenced by Smalltalk 80, I should say not derived, but influenced by Smalltalk 80, it offers static binding of variables and dynamic binding of methods. So, I use the word SD to denote that. Actors is very similar to Smalltalk. Ada offers only static binding, no dynamic binding. C++ offers static binding of variables and some dynamic binding, that is the dynamic binding of methods to messages. Objective-C is very similar, and these all have very nice dynamic binding, and this SS here shows that sometimes you can enforce static binding by declaring the type well ahead in advance, and you can do that to some versions of Smalltalk such as Opal, where you can declare ahead in advance whether the binding is dynamic, whether you want static binding or not. Operator overloading, most of these languages provide some kind of operator overloading except Objective-C, and in Key they say it's plausible, but I am not so sure about it. Kappa and NXpert, they do not offer any such thing as operator overloading, but this may not be very essential in the knowledge based expert system area. Garbage collection. Smalltalk offers garbage collection, Eiffel, Actor they offer, Ada no, C++ no. In Objective-C, I believe it's possible. In class Key, they offer dynamic garbage collection. Kappa and NXpert, we are not very sure what they offer, and this is to be taken with the right spirit. In terms of inheritance, Smalltalk offers single inheritance, and Eiffel offers multiple inheritance. Actor is very similar to Smalltalk. Ada, it's not available, although what you can do in languages such as Ada is, if you do not, you may not have inheritance, but you can simulate inheritance by a process called delegation, where if you don't find the attribute in that particular object, you can tag the object along with the object saying where you can go and find the particular attribute or a value of that attribute. So, delegation process sometimes helps, can be used instead of inheritance, and some people claim that it's a much more efficient way of doing things. Again, I am not very sure about that in terms of whether it's efficient or not. Objective-C does not offer multiple inheritance. They say this is possible. Most of the other languages offer multiple inheritance. In terms of incremental linking, since Smalltalk is an interpretive kind of language, this is not a big issue. In Eiffel, they say it's available in some versions. Again, I have not looked into Eiffel. In C++, it is possible. In Ada, it is possible. Objective-C, it's possible. What we have done in a language called Cosmos that we developed, and we will be demonstrating later on in the application session, is that we have included the inheritance, we have included an incremental linking process where we can develop the C++ object separately and link it along with the other things. However, this is machine specific and cannot be ported very easily across different machines. You use Sun, suppose you are using the Sun computer system, you use something called LDB to do that. It's not very relevant in these languages. Efficiency. Of all these languages, C++ is the most efficient of the lot. Programming environment. Smalltalk has an excellent programming environment. C++ does not have such a good programming environment. However, we are seeing in the market things like Energize from Lucid and Object Centers environment, and a number of other environments which are being sold in the market for doing debugging and browsing objects and so on. Key, Kappa and NXpert, they have some nice programming environments. Dynamic object evolution. In Smalltalk, you can do some dynamic object evolution, and by dynamic object evolution I also mean the following. For example, suppose I have a class and I change the attribute value in that class. Do all the instances get this change propagated or not? In languages which are based on Lisp, you can do that. However, in languages which are based on C or C++, it's extremely hard to do this kind of things. That is, once you have defined an instance of a particular class, and if you have modified the class, the changes in the class are not propagated to the old instances, but are propagated to the new instances. We talked a little bit about parameterized classes before, where the parameterized class allows a parameterized template to be written which can be applied to several cases that differs only in the types of the parameters. And the ADA offers it through only a concept called packages. However, C++ offers this and class offers this. Rest of the languages, it's not very clear what they offer. In terms of software modules, some of the languages such as Smalltalk have software ICs. Objective-C has got used to have very good IC packs, but Objective-C is now currently being being overtaken by C++. So C++ is emerging as the dominant language in the non-Lisp-like languages or non-Smalltalk-like languages. So that is in terms of the Pascal-like languages or C-like languages, C++ is emerging as the dominant programming languages, and there are several reasons for it. In terms of user acceptance of these languages, Smalltalk will mostly be in the R&D environment, although some financial institutions in New York are using Smalltalk for development purposes. Eiffel, we see some commercial implementations. ADA will mostly be in the government type of applications, and C++ will be the one which will be the most widely used. Class is mostly R&D, but you'll see some commercial applications, and some of these things such as Key, Kappa, and Expert have seen some commercial applications, and they may keep on with the commercial applications. What I'm going to do next is to take one of these languages, that is C++, and I will be discussing that with a few examples. And the key concepts that I will be describing in C++ are this notion of class, subclass, the member functions, overloaded member functions, the friend functions, and inheritance. We'll see how these concepts are implemented in C++. Let's take the example of the vehicle which I mentioned before. Here is how you would write a class in C++. C++, which is a language which was developed at AT&T by Strauss-Stoup as an extension to C. So it incorporates all the efficient features of C plus some nice object-oriented extensions to C. If you look at this example here, the way we write a class structure here is that we place all the include files first. Like for example, we used a type called drivetrain here. So we have to include the file include drivetrain.h. Now one of the questions that was asked during the break was, now we are talking about reusable classes. Now do I have to include all these classes as such? And the answer is yes. You have to include all the classes which you are either subclassing or classes are the types that you are using in this particular class, at least in this file, in the .h file. In C++, we have two kinds of files, the .h files and the .c or .cc files, depending on the compiler or the preprocessor that you use. The .h files consists of the class descriptions, and the .c or .cc files consists of the actual code for the functions. And the functions here, the methods here are called member functions, and sometimes the variables are called data members in C++. So the way we define this class vehicle is we have the keyword class, and then we have the name of the class, which is vehicle. Then we open this with then we use this open parenthesis here. Then we declare the variables which are private with the keyword private colon, and then you declare all your variables here. Now if you look here, we are typing this already. Like for example, owner is a type of a pointer to char, ID is of the type int, model year is of the type int, model is of a pointer to char. Now in Pascal this is the other way around, like you have owner and then you have the name of the attribute and then you have the type. In C and C++ you have the type first and then the data member name or the variable name here. Then we have a second thing called protected. Now, the protected attributes, both structure and behavior, can only be inherited and changed whatever it is by the subclasses and not for everyone else. Now, these variables, these are totally encapsulated variables in the private space, and even the subclasses cannot see this private variable, cannot do changes to these private variables, and the only way they can go through to the private variables is through the public interface. Then we have this protected. The variables here can be seen by the subclasses, and they can be modified by the subclasses but not by the external world. Then we have a third part here, which is the public part, where we define all the functions, both the behavior and the structure. For example, here I have something called vehicle, and vehicle, if you look at this particular, if you look at these two functions, we have some identifiers of the type int. This is an extension to C++, where in C++ you don't need to put this thing here, but whereas in C you don't need to put this. In C++ you need to put this in here. And then also you see there are the arguments here are different in these two functions. Now, these two functions, whenever you have the function with the same name as the class, these things are called constructor functions. So when an instance of this class is created, these functions are invoked. Now, why do we have these two functions here? The reason is that if you send a function, or if you invoke this vehicle function with only this argument here, this function will get invoked, or this method will get invoked. And if you send it with these arguments, this function will get invoked. And this is the process of overloading here, and we are overloading member functions here. Remember the overloading concept that we talked about, and depending on the number of arguments here, either this function or this function can get invoked, and these functions are called constructor functions. Similarly, when we destroy the object, the vehicle, which is there's some kind of a sign here, the not sign in the vehicle, so this function will get invoked. Now, one of the things that you have to notice here is that in some of the concepts that we presented a message selector and then a method. So we bind the message selector to that particular method. In C++, the message selector and the method are the same name here. And the way we do the binding is by means of something called virtual. So if you say virtual void diagnose here, when the keyword void is used so that it doesn't return any value, but this function is invoked. So when we give the word virtual here, it means that this in the subclasses that this function can be overridden. So we can have a polymorphic, so we can have polymorphism in the subclasses. There is another function here that I have shown called the friend functions. Now remember, we said that in C++, the private attributes cannot be accessed by anyone else except the interface, such as here, for example, I have get owner interface into the private variables, and you can only get it through this public interface. That's the only way you can access the private variables. But there's one other way in C++ you can do things. For example, the way I can do that is to declare friend functions. Like in this particular class, I have a friend function, and the friend functions can go in and change any of the variables. The friend functions can change any of the variables in the private part of this vehicle. So friend functions are a way to avoid this strict encapsulation process, so you have to use them sparingly. Now I define the class drivetrain, where I have both the private part and the public part again here, and this is the type. So if you look back in here, we have declared this is the .h file that we have included here, and then the drtrain is of the type drivetrain. Again, with respect to the introduction thing that we talked about on classes, class is a subclass of vehicle. So now we declare this class car public vehicle. So now the way we do ISA here is we declare the subclass for a class is now the class car is declared as a subclass of vehicle by this syntax here. Now I used the public here, because if you use public you can derive further classes from here. If you do not use public, you cannot derive further classes from the car class. The private here has got the size in there, otherwise the variables are we can inherit the variables from the vehicle. And now if you look at the constructor for this, we also have to use the only way, remember, we can get to the parents attributes, private attributes, is through the public interface of the parent, and that is how this is declared here. So these particular attribute initializations are peculiar to this particular car here. However, we also want to make changes to the ident, owner and all those things in vehicle, and we invoke the vehicle's public interface so that the changes can be made in those attributes. And here is a diagnose function that we have defined, in C++. This is now the virtual here. If you look at the example, in this case I do not have the here. I am continuing this public onto the next slide here, where I have the function called void diagnosis. So I do not have the virtual here, I only have void diagnose, which means that if in the further subclasses I cannot change this diagnose function. If I want to do it, I just put virtual void diagnose. Now this is some kind of an inline function where I define the function instead of in a .c file in this class itself. I can do that in C++, where here I can invoke, it's writing out something called invoking rules from car diagnosis.rule, where this is an expert system which is attached to this object. In the next section on applications, we will show you a package called Cosmos, and we will show you how we can attach these rules to this particular object through an encapsulated class called IE. Now I have similarly I define the Benz car, and I have the diagnosis and then I have added a new function called design. Now if I were to define this in the .c file, I have to use this scoping operator here, which tells me that this particular function belongs to this particular class, like the design function belongs to the Benz car. So that is a scoping operator in C++. Now that is a very brief 10-minute introduction to C++. C++ offers you much more flexibility and many more complex features, and it's beyond the scope to describe that in detail. Let's go back to the next issue, that is databases. Now we have discussed the programming languages, and now we will discuss databases. In the past few years, we have seen an emergence of several databases. We have seen a lots and proliferation of lots and lots of databases in the market, and you might be confused because each of the vendors, they have been telling that their database systems is better than any other vendor. In general, we have these database systems classified according to the languages. Like Itasca is based on Lisp, Gemstone is based on Smalltalk, Ontos, Object Store, Objectivity, Poet, Versant, they all are C++ based systems. UniSQL, Iris, O2 are C based systems. Along with your notes, you have a report which compares and contrasts a number of object oriented database systems. That report is a little bit outdated, and we will be producing another monograph in the future, and if you are interested, please feel free to send me a note. While you are evaluating these databases, how does one go about evaluating these databases? Now to evaluate these databases, we need to go and look into several features, because it depends on what really your application wants as such. So the kinds of features that I would say that we need to look at are the implementation language, external language interfaces, object data modeling, query management. Let's go through each one of these things. Suppose you have an application which is all in C++, you might be better off going in for a database system which is in C++. On the other hand, if you want a lot of flexibility, and if the C++ database system does not offer that flexibility, you might want to try a Lisp based system. But you have to be very careful on these evaluations which you see in the market about these database systems, because these evaluations, it's very hard to evaluate these databases within the time span, and these features constantly keep on appearing, and new features keep coming into these database systems. So you have to understand that aspect while listening to this as part of the talk. External language interfaces, whether the database provides, suppose you have a database system like a Tasca which is Lisp based. Does it provide interfaces to C++? Does it provide interfaces to C? Many of these database systems do provide interfaces to a number of languages, and if you need it, you have to look into that and otherwise ask the vendor to see if they have that. Again, for some applications such as engineering applications, you might need this several features of object data modeling such as composite objects. What are composite objects? We have seen in the talk on object oriented software development that there is a part of relationship. There is some semantics associated with this part of relationship. That is, suppose I remove one of the subparts, what happens? Suppose I remove the whole component, what happens to the parts? So some of these database systems, they offer certain semantics associated with composite objects, and you can deal with them in a unified manner, and some of them don't offer this facility. Now again, here you have to see whether you really need this composite object facility or not. I would say for engineering problem solving, you definitely need it. Maybe for some other problem solving, you may not need it. Do these things offer multiple inheritance? Again, we feel multiple inheritance is an important aspect, and many of these things are related to the base language such as C++ or Lisp. Some of them are offered in the Lisp, in the language, whereas in some cases the database vendors extend the language to provide these features. Dynamic object evolution. We discussed about dynamic object evolution before, and you need to see whether these things. There are a number of in terms of dynamic object evolution, there are a number of things that you can do to these objects. You can add new attributes, you can add new methods, you can remove attributes, you can remove methods, and so on. Now, are these things propagated down the line to various other subclasses or instances? So you need to look into it too. The fourth is query management. What kind of query management that these database systems offer? Some of them offer SQL-like interfaces like Object SQL. Some of them offer extend C++ or any of the host languages to provide a query management. Some of them may provide query optimization. Some of them may not provide query optimization. Completeness. Are these databases complete in the sense that they have all the features that we talked about previously? Well, some of them offer partial features, some of them offer all the features. But then there's another problem that you need to worry about in terms of these databases, that is performance. If you look at a database, some companies would say that performance is one of the most important things they want. They don't care whether the database can do object evolution, whether it does have a group transaction management system, and so on. And the single most important criteria could be performance and reliability. So again, it depends on what you want with your database systems. In the area of CAD/CAM or collaborative engineering, I'm not so sure that I'm not so sure that we need that much. Reliability is important, but it should not be the sole point that we should look into, but we should look into these other features also that I'm talking about. If you look at the relational databases, when they first came, they had problems with reliability. In fact, many relational database systems still have problems with reliability. So it will take some time for the object database systems to become as reliable as the relational database systems. Now, if you were to wait for only reliability, then you might miss some nice things that could happen in this century. Look at what happened to the VCRs. When they came out, the VCRs were pretty huge. So what happened? We did not buy them. So what is the story now? None of the VCRs are manufactured here. They're manufactured elsewhere. And that's one of the key reasons that we need to look into object databases with little more detail than what we are looking at right now. Transaction management. Whether the system offers a notification mechanism, how flexible are these logs? Like in most of the relational databases, we have only like a read lock and a write lock, or maybe an intentional read, an intentional write, or maybe an SIX lock. In object databases, we have to extend these locks, and the locks have to be fairly flexible. Do we have versions? For collaborative engineering applications, versions are very, very important. Do these database systems support group, nested, shared, and cooperative transactions? How good are the user interfaces? Is it very useful? Is it very easy to develop schemas? In some databases, it might become extremely hard to develop these schemas where you have to know the host language. In some databases, they provide you an interface where you can develop schemas with your mouse, and that's a pictorial schemas are automatically translated into the host language. Security. In many companies, security becomes an important issue because your data is very important to your company. The data consists both the data and the knowledge. So when you are taking chances with data and knowledge and putting it in some place, you want this to be secure, and you don't want other people to access this. You can do this in current databases by having some kind of a security type interface to it. So by means of some password protection, you can allow certain people to access it and certain people not to access it. Whether the data model that you are using in database systems, do they comply with the standard object model? And we will see an emergence of the standard or an acceptance of a standard object model, especially with groups like OMG coming up. Do these databases support multimedia? In terms of support for multimedia, we can do it directly or we can do it indirectly. So whether do they have a strong support, or do they provide some abstractions for multimedia? Do they have a picture class? Do they have a video class? How well are these things integrated into the rest of the package are some of the concerns you should look at. We talked about some of the features of collaborative product development. Do these things systems support it? What kind of hardware these systems run on? Do they run on PCs? Do they run on Unix machines? Again, it depends on what is the hardware that your company is using. Portability. Some systems run on both PCs and the Unix machines. So what you can do is you can develop on a Unix machine and port it without any problems to a PC, whereas in some systems they are only available on the Unix machines, so you are stuck with the Unix machine. So again, it depends on what you want to do with this system. What is the cost? The cost of the systems are falling down every year. So for many of you, cost may not be a big deal. For some of you, cost may be a big deal. Vendor support. Many of these databases in the future may survive, may not survive. So you have to look and then also you have to see at how well this product is supported by the particular vendor. Even when you are testing, the best way to do all these things is to get a few prototypes, and then what you do is to test them against the features that I talked about. And you might even add a weightage factor to these features. All these features may not be really important for you. So add a weight factor in there, and then multiply the weight factor with some factor utility value here, and you might get some number, and you can use that number to evaluate the database system as such. So the vendor support is important because when you get a few database systems to evaluate, you want to know who is the vendor who provides the best support. So what you can do is get these few database systems, and while you are evaluating them, you can constantly keep barraging the vendor with various questions and see how well they respond. Now, vendors may not be willing to give you the systems to evaluate, but again, it depends on the competition and so on, but you should try your luck with them and see if they are willing to give you a system for 1 month evaluation or 2 month evaluation, because we are not talking really here about spending $20,000 or $30,000 for the database. We are also talking about putting a lot of data in there. We are talking about investing time. We are talking about investing people's time, and we are talking about your company's competitiveness in the global markets and a number of other issues which need to be taken into consideration. I will discuss two representative databases that we are familiar with in our laboratory, that is, we have used these two databases, commercial databases. One is Object Store and another is UniSQL. We are now evaluating a number of other databases. As I have mentioned, I will talk about these databases in a future report, and if you are interested, you can always call me or send me a note. Object Store uses C++ as the data definition and the data manipulation language, and it has a number of features which are extensions of C++. Object Store supports parameterized types, and by parameterized types, this is what I mean. For example, here we have a template class here. The way we declare this is we have a template class. We have this two less than greater than sign, class T, and then this is the class container, and the value is of the type T. When you get value, it's also of the type T. Now what happens with this container class is that depending on the type here, like for example, I can declare this particular variable A as of the type of container with integers. So T will take integer. Similarly, if I declare it as car, T will take the type car. So this is a very useful thing. So you can develop some generic classes, and then you can instantiate during runtime with specific types in there. So C++ 3.0 supports that functionality, and Object Store also supports it. Object Store has a number of other features, such as when you define a relationship between two objects, the inverse relationship is automatically generated. You can do it has a number of indexing facilities. You can index directly on the attributes if you want to. There are the transaction macros are basically OS begin transaction and OS end transaction. So when you begin your code, you have to start with OS begin transaction and end it with OS end transaction. I'll be kind of skipping through a number of slides in the next 10 minutes or so, but if you need further detail about these databases, you can either call the vendor, or you can look forward to seeing the report we will be bringing out about these systems. As I said before, in Object Store we can define inverse relationships, and we can also declare we can index the members, which is very flexible. Object Store extends C++ by having things such as for each loops and certain things. So we define the schema as in C++. So what I'm going to do now is to give you a couple of quickly run through an example or two of this of the vehicle system that we generated before in C++ in Object Store. Now Object Store does not support dynamic schema evolution, but however we can simulate dynamic schema evolution, as we will soon see in an example in the next section. So I'm not going to talk about how to create the persistent objects, but what I'm going to do is to show you a few slides and examples that how we have extended the vehicle class definition. In your notes, we also handed out these examples, so you can look at it at your own leisure. So the yellow color here shows the extensions that we made to the example we prepared in C++. So we have to declare the database variable here, the DB, which is a pointer to this database type and of extend. So we declare it extend database. It's an external variable. So DB is a pointer to database. So we include that. And then what we do is that we also defined one Object Store facility is a collection class. Now this OS set is a collection class it is a parameterized class of the type pointers to vehicle, and we declared extent as a type of this, and then we also have to declare this as a persistent variable. Remember the database DB is the persistent database, and if we go back to the previous slide, we have declared DB as a persistent database. So DB here is the pointer to the database. So now we declare OS set as belonging to this database DB, and extent is of that type here, and this is used for putting in the classes of the type vehicle into this extent. Everything else remains the same. So what you can do is, if you already have applications in C++, you can add a few features in there so that now you can directly merge it into the database system. Again, similarly for car, we have declared, you need to declare this only if you have a new .h file. Otherwise, if this class car definition is part of class vehicle definition, you don't need to do it. Here we have declared the OS set, but here the type is car, and again extent is the variable which is local to this one here. Now this variable, we didn't talk about it, but it refers to the individual object. When we create an individual object and we want to refer to it, we use this word called this. So when I do extent.insert, insert is a function. Insert is a message which this OS set can respond to. So this now responds to this message. Extent responds to this message insert and inserts the particular instance that you have created into this OS set, into this extent, which is extent is now a type of collection type. So really what you can do is, to summarize, what you can do is extent is like some kind of a bag or a set, and extent is let us say we can look some kind of a set, and you can throw in the instances into this variable called extent. So extent can be viewed as a set where you can keep inserting in values. It's like a refrigerator where you can open your refrigerator and put all kinds of things. You can put things which are of the type egg, or you can put things which are of the type liquid, or of the type solid, or of the type liquid, and that's exactly what we are seeing here. So we can view extent as your refrigerator where you are going to put eggs and milk and things like that. But extent is of the type OS set, and OS set is an object store defined variable. So now the method is the same here as we have done before, and here is a program, sample program using object store, where now you can there are a number of declarations here in the yellow. The things which are shown in the yellow color are the things that are specific to object store. For example, if you want to create Hussein's car here, remember the BMW car that we declared before, and with number of variables, and then you send the new message to BMW car class. In C++, the way we generate instances are by sending the new message to that particular class. Here we have, in object store, they have modified this new variable by adding a db, by adding some kind of a parameter here or an argument. So now we send this new db, but db is the database that we are looking at, to this class BMW car, and then that I equated to Hussein car, and it's of the type car. So when you do this, what happens is, because you said that when you create this car here, you insert automatically this into this extent variable, which is of the type OS set, and also because we have defined that in the vehicle, it also puts it into the vehicle extent. So the variables are put both in the vehicle extent and the car extent. As shown in here, we open the DB and close the DB. Now I don't have too much time here, so what I'm going to do is to give an example of query. Here is an example of querying that we can do in object store. So if you want, for example, if you want to get all the cars whose owner is Ram, the way you do it is, you have the car, because you use the scoping operator, you are looking into the extent of the car, and then you kind of say, well, get all the variables which are equivalent to Ram here, and then that will be, and you return this collection class here with the single element here which is of the type car. Now we can also get back a list or a set here, like the example which shows here, get all the trucks whose capacity is greater than 1000, and so you can have a number of query functionalities. Now if you look at these queries may not be SQL type queries, but these are queries which are very intuitive for C++ programmers. So in summary, object store is based on C++, and you can migrate C and C++ programs into object store. It has limited schema evolution. It has a user interface which helps in designing the objects that I talked about. You just don't need to write in C++ code like the ones we mentioned. There is also a schema editor where you can edit using the schema editor. I'm not trying to sell any particular object database system here. All I'm telling you is from experience what we have seen with a particular database system, and I could probably giving the same description of other object database systems, but in the interest of time I've only picked up 2 representative database systems. One is C++ based system, and the other system is a C-based system which is called UniSQL, and UniSQL integrates both relational model and the object model. So if you want to program using the relational database concepts, you can do that in UniSQL, and if you want the object model, you can do that in UniSQL. UniSQL incorporates dynamic object evolution, and it provides inheritance facilities for tables. In the traditional notion of a relational table, we have the concept of normalization, so we put it in first normal, second normal, and third normal forms. However, when we put it in first normal forms, the attributes have to take only atomic types and not complex types. In UniSQL, the attributes can take complex types, and tables can inherit attributes and methods from their parent tables. The user interface is very nice, and it's implemented in C++. Again, here is an example schema that we talked about before, and what I will do is to show you how this is done in UniSQL. You can do it either using the schema editor or writing class definitions as shown here, where I'm creating a class employee. Again, this is something like little bit like Pascal here, where the social security number is of the type char, name is of the type char. There's a picture which is a X11 bitmap. Note that along with this table, I can also add methods here. There is a method which gets invoked when we send the message show picture. The method that gets invoked is the function show picture. So you can mix along with these tables the methods also. Only thing with UniSQL is that most of these attributes are public. So we don't have a notion of private attributes here. These are all the function, these are all public attributes. Both the attributes, so that means the structure and the behavior, both the things are public. So we can go on in defining the rest of the objects here. And I'm not going to go into too many of these objects because you already have these things in your handout. So the way we do now, UniSQL offers an SQL-like interface. So here is an example of an SQL interface for this particular illustration that we are showing. This is the same example that I showed before for querying, where we want to select the vehicle.id, where the color is blue, the manufacturer's location is Detroit, and the manufacturer's president's age is less than 50, and this is how we do it in UniSQL. Note we can go navigate through various objects like manufacturer, dot location, dot name, and if you go to the previous example around here, you can see that if you look at this vehicle, the vehicle has got manufacturer dot location will give me this, and location dot age will give me this. So in summary, UniSQL has got embedded SQL. You can do relational and object models, provides dynamic schema evolution, as a query management which is compatible with SQL, and it facilitates multimedia integration. And finally, I will spend about 30 seconds on case tools. There are a number of case tools which are available in the market, such as the ones shown here: Teamworks, PTech, OMT, Rational Rows, Demeter, IDE, Tiger, Marvel, etc. And these case tools can be used to develop some of the, they map directly from an intuitive interface on directly into the code in appropriate language such as C++. But again, these case tools right now are not tightly integrated. So to summarize, there are lots of object-oriented tools, and users must decide features for evaluations, they must get a golden set of features, and then they have to give weights to these features and they evaluate based on these features. The best way to get to know these databases and programming languages is to compare several tools by developing prototypes, and a seamless integration with already applications which are there will facilitate acceptance of these object-oriented systems better by the users. Thank you, and we will in module 5 we'll talk about a number of applications that we have developed using some of the tools that I have just mentioned.